Hello everyone, I'm making this video to explain how it's going to be done. The calculations related to the visible spectroscopy laboratory. The first thing you need to keep in mind is the initial concentration that you can see here. This concentration is that of the blue dye assigned to you in the laboratory. From that point in the process, you are going to carefully prepare a specific chemical solution. Since you have been provided with a 50 milliliter volumetric flask for this task, you will first add to that flask the specific dye assigned to you in the laboratory today, which would be exactly 1 milliliter of that concentrated dye. After that, you must fill the rest of the container with pure distilled water until you finally reach the graduation mark, the 50 milliliter mark. How is the calculation done? Well, if I start with an initial concentration of 2.6 times 10 to the minus 3, which is the concentration of the dye, I multiply it by the volume that I took from that solution, and that will be equal to the new concentration that I just prepared in the volumetric flask multiplied by the volume of the flask, which would be 50 milliliters. 50 milliliters and 50 milliliters cancel each other out. Therefore, to find the concentration, I would have to divide 2.6 times 10 to the minus 3 by 50. This specific calculation will give you the exact molarity of the chemical solution you prepared. In order to make the very first absorbance measurement, that will be carried out during this part of the laboratory experiment. This specific formula that you see here is very important, because it will allow us to accurately calculate the concentration of the Windex, the mouthwash, and the Gatorade. Once I have made several absorbance measurements, this initial concentration that I had here will be diluted, with each step diluting it by half. You are going to make a graph where you will plot absorbance against concentration, and that graph will give you a straight line with an equation of y equals mx. The slope is exactly this term here. Once you calculate the slope, I could rewrite it as mc. If I want to know the concentration of dye in the Windex or in the mouthwash, all I have to do is divide the absorbance I measured by the slope, and that will give me the concentration of each of the solutions that were tested at the end of the lab. Notice how your graph will look more or less like this when you plot molarity against absorbance. I recommend including the intercept at 0 to avoid having to add this value, which would be the intercept. You can set the intercept to 0 and make your graph when collecting data. These are the data that will help you make your graph. You're going to write down the molarities we've had and the absorbance values, for example. I can say that one of the possible values for the first solution could be 1.6 times 10 to the minus 3. And theoretically, the equivalence could be 0.5 on your spectrophotometer. And you keep calculating like that. Once again, this is the formula used to calculate concentrations when diluting, and the rest are explanations of the procedure that must be carried out. Observe, at the end, there is another table where you will identify which substances were used. For example, the mouthwash. Here you write the absorbance you obtained. I'll put a hypothetical value, 7. And the concentration is calculated only once you have obtained the slope of the line. Once you have that slope, then write the absorbance you obtained in that measurement multiplied by the slope or concentration. And this allows you to put it once you divide the absorbance by the slope. This is the value that goes here, that concentration. And likewise for the next one, which isn't so unknown because you already saw the name. It would be the Gatorade, which is the other one, and the Windex, which would be the other substance that contains blue dye. That would be the general explanation of what you need to do in this lab. Thank you very much for your attention.